A gallon of gasoline contains 1.3 times 10 to the 8 joules of chemical energy. A particular car converts 20% of this chemical energy into work that counters the overall drag force on the car as it moves. If the average drag force is 650 newtons, what gas mileage will this correspond to? Now, I'm going to use the concept of work is equal to change in energy here, but I might be abusing this concept a little bit here. I think the key thing to what I'm looking at here is we're looking at like work input by the engine, which I'm going to think of as like maybe an available amount of energy. And I'm actually going to associate that with the delta E side of this equation. In other words, I'm going to say the amount of available energy here is equal to 20% of the 1.3 times 10 to the 8 joules in 1 gallon of gas. So I'm just going to put those numbers in there, 0.2 times 1.3 times 10 to the 8 joules. And I'm going to leave those uncalculated for right now because we're going to do something else with it. But I'm going to equate that to the amount of work done against this drag force. But we know the drag force is 650 newtons. So maybe I could say, well, 650 newtons times some unknown displacement. So what I'm thinking about here is I'm saying, well, for 1 gallon of gas with a 650 newton drag force, there will be an unknown displacement d. Well, if I figure out what that displacement is and convert it into miles, that would be the amount of miles the car went for 1 gallon of gas, which is basically the gas mileage, right? So in other words, I'm just going to solve for d. And so d, I think here is equal to, if I divide both sides, we got 0.2 times 1.3 times 10 to the 8 joules divided by 650 newtons. And a joule divided by a newton, recall that a joule is a newton meter. It makes sense that we're doing all SI. This is a distance. This should come out in meters. And it winds up being 40,000 meters. Pretty much exactly. So actually more than pretty much, basically exactly. Isn't that amazing? If you divide that by 1609, because there's 1609 meters in a mile, you wind up getting like around 24.86 miles. And I think that's already, let me double check here. That's already a little bit rounded, but maybe I want to round it a little bit further and therefore claim, since everything here was presented to me at kind of a two significant figure level, that maybe this leads to a 25 mile per gallon gas mileage. So let's go ahead and check that answer and see if that works out. Looks like it did.